Welcome to Channel Cosmic Lullaby Channel. Hello there, and a very warm welcome to this quiet space, a gentle harbor from the waking world. Tonight, we will drift together into one of the most extraordinary and ancient civilizations on Earth, the hidden realm of bugs and insects. It is a world that breathes just beneath our own, a silent and sprawling society that stretches from the deepest soil of the forest floor to the very edge of the endless sky. This civilization is older than the first forests that ever stretched their branches toward the sun, and its citizens are more numerous than all the stars we see twinkling in the vast, dark expanse above. They are the planet's first architects, its original artists, and its most tireless custodians. Beneath every leaf that trembles in the breeze, within every fallen log returning to the earth, and inside every gentle breath of air, they work in a quiet and profound harmony. They are meticulously shaping our planet in ways we rarely see, but in ways we always and completely depend on. They are the unseen pollinators for much of the food we eat, the silent recyclers of the fallen forests, and the painters who fill the air with mesmerizing patterns of motion and of color. Some among them light up the soft darkness of the night, transforming a forest into a living constellation. Some have learned to farm their own crops deep underground, and others have mastered the art of navigating by the distant stars. In their world, which hums with a life force all its own, strength takes on 1,000 different forms, and a deep instinctual intelligence hides in the smallest of minds. This is a world not of grand gestures, but of infinite, delicate details. A natural male narrator voice with a warm, friendly tone. Think of a story written in chitin and dust, in moonlight and shadow, a testament to the resilience of life in its most varied and surprising forms. If you find comfort in these quiet journeys of ours, I warmly invite you to like, subscribe, or perhaps share a thought below. Your presence helps others find their way to this sanctuary, one sleepy soul at a time. But for now, all you need to do is breathe. Simply allow your eyes to grow heavy and let the gentle, whispering world of wings and whispers carry you softly into a deep and peaceful sleep. Soft, wondrous, and perfectly still. Let us begin. There are more insects on Earth than there are stars in the Milky Way. It is a truth so immense it gently pulls at the edges of our understanding, asking us to release our human scale and float into a vaster perspective. The sheer scale of insect life is truly beyond our waking imagination. Scientists have made estimates suggesting that there are quintillions of individual insects alive at any given moment. A quintillion is a 1 followed by 18 zeros, a number so vast it completely eclipses the count of all the stars in our home galaxy. Beneath every patch of soft soil, inside every piece of fallen wood, and within every gust of warm summer air, they thrive in an endless, breathtaking variety. If you were to cup a single handful of rich earth, you might be holding thousands of hidden lives, each one turning, eating, building, and transforming the planet, one tiny grain at a time. Insects outnumber humans by a factor of billions to 1, and in ages past, their combined weight was thought to rival that of all other animals on land combined. They are not merely a side story in the grand narrative of life on Earth. They are its very foundation, the silent, load-bearing architecture upon which everything else is built. Their existence serves as a gentle but profound reminder that our world is not shaped solely by the large and the powerful, but by the small, the numerous, and the persistent. They are the quiet laborers, working in a silent, synchronized unison across all the continents, largely unseen, yet utterly and completely unstoppable. And among these tireless workers, few are as astonishing in their unity as the ants, whose colonies function with the coherence of a single superorganism. An ant colony can contain thousands, or in some cases, even millions of individuals, and yet it behaves as if it were a single living body with a single unified consciousness. Each ant has a specific and coded role. Some are foragers, gathering food for the collective. Some are nurses, caring for the colony's young. Others are soldiers, guarding the entrances, while a dedicated few tend to the queen, the heart of the entire operation. There is no single ant that commands the rest. There is no hierarchy of authority, no central command. Instead, they communicate through a complex and beautiful language of scent trails and chemical signals, forming a living, breathing network of perfect coordination. When one ant discovers a source of food, the entire colony responds in moments. When danger strikes at the gates, they move as one to defend their home. Together, through this selfless and intricate cooperation, they build vast underground cities with labyrinthine tunnels and perfectly organized chambers, each one ventilated with an architectural precision that continues to inspire human engineers today. Their collective teamwork rivals the astounding efficiency of the human brain itself, with each individual ant acting like a single neuron firing within a much greater shared intelligence. To watch them is to witness a form of collective consciousness, ancient and precise, a quiet reminder that true cooperation can be just as powerful, if not more so, than brute strength itself. From the vast, unified mind of the colony, we now drift to the quiet solitude of the individual, where the world is understood not through a network of shared signals, but through the most intimate and personal of senses. Consider the butterfly, whose world is shaped not only by the vibrant dance of color and light, but by the invisible and intricate chemistry of the air itself. On their slender, delicate legs lie tiny, specialized receptors, sensory organs that can detect the faintest traces of nectar, the subtle sweetness of sap, or the unique chemical signature of a specific host plant. When a butterfly gently lands upon a leaf, it is, in a very real sense, tasting it through its feet. This single, silent touch is a profound act of knowing, a moment of deep inquiry to determine if this exact leaf is the right place, the perfect nursery to lay its precious eggs. This sense is so exquisitely sensitive that a butterfly can detect sugar dissolved in water at a concentration as weak as just a few drops within an entire swimming pool. For the butterfly, every surface it touches holds a story, a detailed and vital narrative. A story of what it offers, what it might hide, and what new life might grow from it. Their magnificent wings are instruments of beauty and of flight, painting the air with fleeting color. But their feet are instruments of knowing, connecting them to the landscape with an exquisite and absolute precision. Every single landing is a quiet conversation with the world, a dialogue carried out in the silent, universal language of chemistry. Now let us leave this world of delicate touch and drift into a world made almost entirely of motion. Here, the dragonfly reigns supreme, a master of the air. Dragonflies live within a shimmering sphere of vision. Their enormous compound eyes wrap almost completely around their heads, each one containing tens of thousands of individual lenses. These are not eyes as we understand them, but living mosaics of information, each tiny lens capturing a different fragment of the world. This structure gives them a panoramic view so complete and so seamless that they can track movement in nearly every direction at once, without ever needing to turn their heads. They can perceive colors that lie far beyond the limits of human vision, including the ethereal glow of ultraviolet light, which paints flowers and pathways with patterns we will never see. And they perceive motion with a breathtaking, almost impossible accuracy. To a dragonfly, the frantic beat of a mosquito's wing is not a blur, but a distinct and visible rhythm, a predictable pattern they can anticipate and intercept in midair with effortless grace. Their hunting success rate is among the very highest in the entire animal kingdom, and this is because their vision is not just reactive, it is almost predictive. It allows them to sense where their prey is going to be a fraction of a second before it actually gets there. They do not chase, they simply arrive. Watching a dragonfly dart and hover across the still surface of a pond is to witness pure precision in motion, a creature guided by an ancient and perfect design that makes them among the most skilled and elegant aerial hunters ever to evolve on this planet. From this master of the air, our journey now takes us to the ground, to an order of creatures so diverse and so numerous that the story of life on Earth could almost be told through them alone. These are the beetles. Beetles make up a staggering 1/4 of all known animal species on our world. There are more than 400,000 described species, and likely millions more yet to be discovered, each one uniquely and wonderfully adapted to its environment. Some glitter with the iridescent sheen of jewels, their shells refracting light into a rainbow of metallic hues. Others are built like miniature tanks, their bodies armored and seemingly indestructible. And a few live in places where almost nothing else can possibly survive, from the driest deserts to the hottest volcanic vents. Their diversity is so mind-boggling that when a scientist once asked a theologian what his studies had revealed to him about the nature of God, the theologian replied, half joking, that the Creator must have had an inordinate fondness for beetles. They burrow through the soil, glide silently beneath the bark of ancient trees, swim gracefully underwater using trapped bubbles of air, and they feed on everything from the finest pollen to fallen dung to the slow, sacred process of decay itself. Their armor-like shells, called elytra, and their intricately folded wings have inspired artists for centuries, and now inspire engineers and even robotic designs. Every beetle, no matter how small or how seemingly insignificant, carries within its body a piece of our planet's long story. It holds a legacy of endurance and adaptation, a history written in the resilient language of chitin and color that stretches back hundreds of millions of years, far into the deep past of our world. They are the quiet, armored keepers of time, a living library of evolution's most successful and enduring ideas. Now, let us venture from the world of silent, armored forms into a realm of pure communication, a society that thrives on a language written not in sound, but in movement alone. In the secret, humming twilight of a hive, honeybees share intricate maps of the world using nothing but the rhythm of a dance. When a worker bee, a diligent forager, discovers a new and promising patch of flowers, she returns to the absolute darkness of the honeycomb and begins a performance. The pattern of her steps, the precise angle she faces, and the speed and duration of her waggling body all combine to tell her sisters exactly where to fly and precisely how far. This waggle dance is one of the most sophisticated and abstract forms of communication in the entire animal kingdom, a miracle of symbolic representation. Other bees gather closely around her, not watching, for there is no light to see, but touching her with their antennae, feeling the vibrations and the rhythm to decode the vital message. Together, they navigate using the sun's position as a celestial compass, a remarkable feat made even more so by their ability to calculate its location even when heavy clouds hide it from their view. Each dance carries not just raw information, but a sense of shared purpose, a directive that speaks of food, of survival, and of the collective pulse of the hive itself. Within the deep, fragrant darkness of the honeycomb, they create a living geometry, a conversation of motion and of meaning. It is a language built from angles and vectors, a silent, intricate ballet that turns a single bee's discovery into the coordinated effort of thousands. From this kinetic language of the hive, we drift now to another form of silent communication, one that illuminates the warm summer darkness. The fireflies create their gentle light using a perfectly efficient chemical reaction, a form of biological alchemy that human science still struggles to replicate. When the firefly glows, absolutely no energy is wasted as heat. Its soft, cool light is produced by a reaction between oxygen, calcium, and a wondrous compound called luciferin, all orchestrated within the tiny, delicate lantern of its abdomen. This biological process is 100% efficient, a perfect conversion of chemical energy into light. The gentle rhythm of a firefly's glow is both a form of communication and a delicate courtship, a coded signal that can attract a mate or warn off a potential predator. In some magical places, thousands of them gather in synchronized, harmonious rhythm, lighting up an entire forest as if it were a single breathing constellation, a reflection of the starry sky here on Earth. Each individual flash is a quiet whisper of biochemistry, a miracle that turns life itself into a source of gentle illumination. For millions of years, they have lit the warm, still air of summer nights. These tiny alchemists converting simple molecules into pure radiance. They serve as a soft reminder that even the smallest and most fragile of creatures can hold the secret to nature's most elegant and perfect designs. From the fleeting light of the firefly, we turn now to a structure of profound endurance, a testament to what can be built from the earth itself. The termites build air-conditioned cathedrals of clay. Their mounds are not just piles of dirt. They are living architectures, breathing structures that manage air, heat, and humidity with an astonishing and unwavering precision. Some of these towers can reach heights taller than a person, monuments of instinct rising from the savanna floor. Yet every single chamber inside is perfectly tuned to the specific needs of the colony. A complex network of vents and tunnels creates a natural convection current. Warm, stale air from the colony's collective breath rises through a central chimney, while cool, fresh air is drawn in from vents far below. This system maintains a steady, constant temperature inside the mound, even under the relentless heat of the burning sun. No single termite understands the blueprint for this magnificent structure. There is no architect, no foreman. But together they build as if guided by a single collective instinct, an ancient wisdom encoded in their very being. The design is so ingenious and so efficient that modern engineers have studied termite mounds to inspire self-cooling, sustainable buildings for humans. Deep inside, a single queen, the heart of the colony, may lay thousands of eggs each day, while legions of workers tend to sprawling fungus gardens and care for the young larvae. The mound becomes a living machine, a city perfectly balanced between the forces of chaos and order, created entirely from earth, saliva, and the slow, patient passage of time. It is one of nature's grandest and most mysterious architectural miracles, built by creatures barely the length of a single grain of rice. From the grand collective architecture of the termite mound, our journey now leads us into a much darker and more intimate corner of the insect world, where the strategies for survival become both chilling and strangely beautiful. Among the most unsettling behaviors in this hidden kingdom lies the precise and haunting strategy of the parasitic wasp. There are many kinds, and each has perfected a delicate yet terrible art. A female will find a specific host, often a caterpillar or a spider, and with the skill of a surgeon, she will sting it just enough to paralyze it completely. The host remains alive, its heart still beating, but it is rendered utterly helpless, transformed into a living cradle, a breathing nursery for the larvae that will hatch within. The wasp then lays her eggs, sometimes one, sometimes many, inside the still living body. As the young begin to grow, they feed with a chilling and remarkable precision, carefully consuming non-essential tissues first, instinctively avoiding the vital organs to keep their host alive for as long as possible. It is a chilling yet profound display of evolutionary programming, a testament to nature's perfect balance between creation and destruction. Many of these parasitic wasps target insects we consider pests, and their silent, deadly work keeps entire ecosystems in check, preventing any one species from overwhelming another. They are both the executioners and the guardians of this world, shaping populations quietly and unseen through their deadly, intricate choreography. Within their delicate, shimmering bodies lives a logic as ancient and as impartial as the earth itself. The unwavering instinct to ensure that life continues, even through the most haunting and unsettling of means. From this shadowy dance of life and death, we now rise into the light, into a story not of a few weeks, but of many, many years. It is the story of the cicada, a creature that can sleep underground for more than a decade before it ever sees the sun. Beneath the tangled roots of ancient forests and quiet fields, cicadas live a long, slow, and patient childhood. For 13 or sometimes even 17 years, they feed in the silent darkness, nourished by the sap of roots, silently waiting for a signal, a specific season, a perfect moment to rise. And then, when the time finally comes, all at once, millions upon millions emerge into the light, transforming the entire landscape into a single, vibrating chorus of sound. Their perfectly synchronized appearance is one of nature's most extraordinary and mysterious acts of timing, a strategy thought to be an evolutionary trick to completely overwhelm their predators with sheer, unimaginable numbers. After so many years spent dreaming beneath the soil, their lives above ground last for only a few fleeting, glorious weeks. They sing their hearts out to the sun, they mate, and they leave behind the next generation to begin the long, patient cycle all over again. Every empty shell you find clinging to the bark of a tree, every shimmering, hypnotic song that fills the warm summer air, is part of a rhythm that has played out for millions upon millions of years. It is a profound reminder that even the very briefest of lives can be part of something vast, ancient, and truly enduring. Now, let us leave the deafening chorus of the cicadas and sink into a world of profound stillness, a world of waiting. Among all insects, the praying mantis stands apart, moving with an alien grace and an almost unsettling intelligence. It is one of the very few insects capable of turning its head from side to side, sometimes a full 180 degrees, nearly looking behind itself. This incredible gift of movement gives it a panoramic, almost conscious awareness of its surroundings. Its large, compound eyes can detect motion hundreds of times faster than the human eye, while 3 smaller, simpler eyes on its forehead help it to gauge light and distance. A mantis can spend hours perfectly motionless, its folded forelegs poised like hands clasped in prayer. Yet the very instant that its prey comes within reach, it strikes with a lightning precision that is almost too fast for our eyes to follow. Watching one slowly tilt its head toward you feels uncanny, as though it is not just seeing you, but is truly aware of being seen. The mantis lives its life in a world of stillness and of cool, quiet calculation, a patient predator wrapped in serene beauty, existing somewhere in the mysterious space between tranquility and danger, where silence itself becomes the perfect hunting strategy. From the patient hunter waiting in the leaves, we now lift into the open sky, following one of nature's most fragile and yet most epic journeys. Every year, the delicate monarch butterflies undertake a voyage that spans an entire continent, guided by an inner map written in the ancient languages of sunlight and magnetism. Their journey begins in the cool northern regions of the United States and Canada, and from there they glide ever southward, a silent, drifting river of orange and black. They cross vast mountain ranges, mighty rivers, and sun-scorched deserts, all to reach a few specific sacred mountain forests in the heart of central Mexico. The journey can span thousands of miles, a feat of endurance that seems impossible for such a delicate creature. Yet the greatest miracle is this: no single butterfly completes the full round trip. It takes several successive generations to continue the great migration cycle. A butterfly that leaves the north will not be the one to arrive in the south, nor will its offspring be the ones to return. Each generation somehow knows the path, as though the memory of the journey were an inherited dream, a whisper passed down through the very fabric of their being. Their wings are as thin as paper, and yet they carry a strength that completely defies their fragility. Scientists believe they use the precise position of the sun as their primary compass, and can sense the Earth's magnetic field to orient themselves, instinctively adjusting their course day by day to stay true to the invisible path. When they finally arrive at their destination, millions upon millions cluster together in the cool high forests, their orange and black wings turning the trees into living tapestries of endurance, beauty, and profound instinctive navigation. They become a single breathing organism, a silent testament to a journey guided by a wisdom that transcends individual life. From this incredible feat of endurance, we turn to another, a story of survival so strange it almost defies belief. In one of nature's most bizarre and audacious feats, certain beetles have evolved to endure the unimaginable. A natural male narrator with a warm, friendly tone. They remain alive, conscious, and patient inside the predator's stomach. Their hard, smooth outer shells, their elytra, protect them from the potent digestive acids, and a remarkable ability to withstand low oxygen environments allows them to simply wait for their moment of escape. After surviving for hours in what should be their grave, they begin to move, crawling determinedly up through the frog's digestive tract and out through its mouth, or, in some cases, even its vent, emerging seemingly unfazed and unharmed by the entire ordeal. This bizarre and brilliant strategy gives them a second chance at life, in a place where nearly every other creature would find only a certain and swift ending. Scientists who study this phenomenon describe it as a living example of evolutionary audacity. These small, unassuming beetles have, through millions of years of adaptation, turned their predators into temporary, unwilling shelters rather than tombs. Their defiance is a quiet and profound marvel, proof that life adapts in ways that often defy our reason, enduring not just through strength, but through sheer wit and a toughness hidden beneath an unassuming shell of chitinous marmor and unwavering determination. From the solitary survivor, we return to the collective, where survival depends not on individual resilience, but on the strength of the many. Ant colonies, though comprised of tiny individuals, wage organized wars against their neighbors that mirror the complex strategies of ancient human armies. When the territories of two rival colonies meet, they engage in pitched battles fought with an astonishing level of organization. Scouts are the first to locate the enemy lines. A natural male narrator spreads through the ranks like war drums, and in moments, waves of soldiers converge in highly coordinated, disciplined formations. Some species capture their enemies and force them into a life of labor, while others battle relentlessly until one side is destroyed entirely. During these brutal wars, individual ants will sacrifice themselves without a moment's hesitation, their loyalty to the colony absolute and unbreakable. The fighting can last for days, with thousands of ants perishing for the sake of territory or vital resources. And yet, the aftermath is not chaos, but a quiet, orderly renewal. The survivors immediately begin to rebuild. They carry away their fallen comrades, and they begin their lives again beneath the soil. This ancient cycle of conflict and cooperation has unfolded for millions of years, a silent epic played out beneath our feet. To watch it closely is to see both the ferocity and the profound unity that define the insect world's most disciplined and ancient armies. From the complex societies of warring ants, we retreat to the quiet, solitary realm of a creature that demonstrates raw, almost unbelievable resilience. Few living things demonstrate this quality as vividly and perhaps as unsettlingly as the cockroach. Its body is governed not by a single central brain, but by a decentralized nervous system, a network of nerve clusters spread throughout its form. This distributed intelligence is the secret to its legendary ability to continue living even after being decapitated. Without a head, it can still move, respond to the faintest touch, and carry on its normal activity for several days, or in some cases, even for weeks. This is possible because a cockroach does not breathe through its mouth or nose as we do. Instead, it draws air through tiny, specialized holes in its body called spiracles. Its headless body continues to function, to walk, to sense, until it eventually dies, not from the catastrophic injury, but simply from thirst, unable to drink without a mouth. Cockroaches have existed in this form for hundreds of millions of years, a design so perfect and so efficient that it has scarcely needed to change since the age of the dinosaurs. They have survived every single mass extinction event the planet has ever endured, adapting to nearly every environment on Earth. Though they are often seen as simple pests, they embody a kind of stark evolutionary brilliance. They are a living lesson in pure persistence, a quiet proof that survival ultimately belongs not to the strongest or the fastest, but to those who can endure, adapt, and quietly, stubbornly continue. From this story of almost indestructible life, we now turn to a different kind of resilience, not the power to withstand injury, but the power to renew. The stick insect's strength lies not in speed or in armor, but in patience and in regeneration. When one of these creatures loses a leg to escape the grasp of a predator, it does not mourn the loss. It is a calculated release, a sacrifice for survival. Instead, it simply waits for its next molt. Each time it sheds its outer skin, a new limb begins to grow, forming gradually and perfectly until it becomes fully functional once more. This remarkable ability to regenerate is rare among insects and is most effective in their youth, when growth is still rapid and constant. While it heals, the stick insect remains perfectly still, relying on its flawless camouflage to stay hidden among the twigs and the leaves. Its entire survival depends on this silence, on this profound invisibility, and on the slow, steady, and patient passage of time. Every new limb that grows is a quiet victory, a proof of resilience written in the gentle rhythm of molting and of renewal. In its absolute stillness, it endures, and in its quiet patience, it thrives. From the creature that masters stillness, we now turn to one that masters the very forces of physics. Flies, in their own humble way, turn the impossible into routine. Their feet are marvels of microscopic engineering, equipped with tiny claws and adhesive pads that allow them to cling effortlessly to perfectly smooth surfaces, such as a pane of glass or a ceiling. Each of these pads is covered with thousands of microscopic hairs that secrete a thin, invisible film of liquid, creating a powerful molecular-level adhesion. This allows the fly to walk completely upside down without slipping, held in place by invisible physical forces that bind it to the world. The overall mood of an ordinary, everyday nuisance buzzing at a window is in fact a masterpiece of natural engineering. The fly's effortless and complete defiance of gravity shows that evolution's solutions are often most elegant in their simplicity, allowing the smallest of creatures to perform acts that seem to defy the fundamental rules of the physical world. From this small wonder, our journey now takes us to a true giant, a creature that redefines our sense of scale in the insect world. Hidden in the dense, humid rainforests of Africa lives one of the true titans of its kind, the Goliath beetle. With its gleaming armored shell and its muscular frame, a single adult can weigh more than a small mouse. Some males grow to the length of a human hand, their powerful bodies marked with striking, beautiful patterns of black and white. Despite their immense mass, they can still take to the air. Their powerful wings unfold from beneath their heavy elytra like sheets of living articulated metal. Their larvae are even larger, consuming decaying wood for years until they reach the size of small rodents. These gentle giants are completely harmless to humans, but they are monumental in their presence. They remind us that size and scale are always relative in nature's grand and varied design. Within their glossy, polished shells lies a history of endurance, adaptation, and a quiet strength that spans millions of years. The Goliath beetle is one of nature's most beautiful paradoxes. Immense yet gentle, ancient yet ever renewed with each new generation that emerges from the rich, dark soil of the forest. From the gentle giant of the forest, we now turn our attention to a creature far smaller, yet infinitely more influential in the human story. Mosquitoes find us not by sight, but by following the invisible currents of our breath and scent. Every time we exhale, we release a faint, warm trail of carbon dioxide, and they can detect this subtle signal from many meters away. Once they sense this plume in the air, they follow it with an unwavering and ancient instinct, flying against the gentle breeze until they find its source. As they draw closer, other cues guide them: the warmth radiating from our bodies, the specific chemical signature of our body odor, and even the unique blend of compounds on our skin all help to pinpoint their target. It is a known fact that some people are simply more attractive to mosquitoes than others, a preference dictated by a complex interplay of genetics, individual blood chemistry, and even a person's metabolic rate. These tiny, delicate hunters are guided by an ancient instinct that has made them one of the most successful and wide species on the entire planet. Long before the first humans ever walked the earth, mosquitoes were already feeding on the blood of dinosaurs and burly ancient mammals. Their remarkable ability to track life through the air itself makes them both endlessly fascinating and uniquely formidable. In their delicate, almost silent flight, there lies a profound balance of beauty and of menace. a quiet proof that even the smallest and most fragile of creatures can shape the course of evolution and the destiny of civilizations. And as they navigate by scent, another nocturnal flyer navigates by a far more distant light. Moths have traveled for countless generations by the soft silver glow of the moon. They orient their flight by maintaining a constant, steady angle to this reliable point of reference in the vast, dark sky. This celestial compass allows them to glide with purpose across immense distances in near-perfect silence. Artificial lights, however, have introduced a tragic confusion into their ancient and elegant navigation. Drawn irresistibly to the brightness of a street lamp or a porch light, they spiral endlessly and erratically, mistaking the nearby glare for the far-off, steady glow that once guided their ancestors through primordial forests and open fields. Their soft, dusty wings brush against hot glass and open flames, and they become victims of their own perfect precision in a world that has become imperfect and filled with new deceptions. In the untouched wilderness, however, they still move with a quiet and mesmerizing grace beneath the silent stars, following the very same paths their ancestors traced when the night sky was their only map and their only guide. Their journey is a poetic, gentle echo of the old earth, a fragile and beautiful flight, guided by pure instinct, by ancient light, and by the steady, unhurried rhythm of time itself. From this celestial navigation, we return to the forest floor, to a world of brilliant and cunning deception. In the constant, silent struggle between predator and prey, some caterpillars have evolved a truly remarkable and theatrical disguise. When they are threatened, they lift the front part of their bodies and reveal astonishing patterns that perfectly mimic the eyes and scales of a small snake. The illusion is startlingly convincing, made even more so by the slow, swaying motions they make, which perfectly imitate a serpent that is ready to strike. This trick is pure theater, a perfect and calculated bluff that can send a hungry bird fleeing in confusion and fear. This incredible transformation from a harmless leaf-eating larva into a frightening and threatening imitation is an exquisite example of natural selection at its most creative. By mastering the art of inspiring fear rather than taking flight, these clever caterpillars survive long enough to become butterflies or moths. In the quiet stillness of a leaf, they remind us that courage can take many, many forms, and that survival often depends on creativity and imagination just as much as it depends on raw strength. From this master of disguise, we turn now to a creature whose intelligence is not in what it pretends to be, but in what it can remember. Within the humming, orderly world of a hive, honeybees possess a surprisingly complex and subtle intelligence. Recent experiments have shown that they can recognize and remember individual human faces, distinguishing one person from another with accuracy even after several days have passed. They achieve this feat using the same sophisticated pattern recognition abilities that help them to identify countless different species of flowers. Their brains are smaller than the head of a pin, yet they can process complex visual information with a stunning and beautiful efficiency. This ability allows them to navigate crowded and ever-changing landscapes and to return unerringly to their hidden hives from miles away. Bees, it seems, think in patterns, in shapes, and in contrasts, perceiving the world not as a series of simple, static images, but as a living network of relationships. So the next time a bee hovers near your face, it might not just be reacting to your scent or your color. It might be actively observing, learning, and remembering. It is one of nature's gentle reminders that intelligence comes in an infinite variety of forms, and that even a creature born of wax and of sunlight can remember the face of another being. From the gentle mystery of memory, our journey now takes us to a creature that embodies a far more explosive and immediate form of genius. When it is threatened, the bombardier beetle transforms itself into a living miniature weapon. Deep inside its abdomen, it maintains two separate chemical chambers, holding the ingredients for a volatile and instantaneous reaction. When danger is imminent, these two chemicals are mixed, producing an immediate and explosive result. In a fraction of a second, the beetle fires a fine, targeted jet of boiling, noxious liquid directly at its attacker, a liquid that can reach temperatures hot enough to burn skin. The entire mechanism is a marvel of evolutionary engineering. The explosion is controlled by a tiny, intricate valve system that prevents the beetle from harming itself, directing the blast with pinpoint accuracy. Each burst is accompanied by a distinct and audible pop, the sound of pure chemistry being turned into a perfect and effective defense. This incredible adaptation has fascinated scientists and engineers for decades, inspiring research into new forms of miniature propulsion systems and controlled chemical reactions. The beetle's defense is not an act of aggression, but one of pure survival, made elegant through its absolute precision. The overall mood of nature, through the slow and patient work of evolution, can invent mechanisms as complex and as sophisticated as any human machine, all hidden within a creature small enough to rest gently in the palm of your hand. From this master of chemical defense, we now descend deep into the earth, into the quiet, humid darkness beneath the forest floor. Here, the leafcutter ants tend to vast, sprawling gardens that rival the complexity of any human farm. They meticulously cut small fragments from leaves, not to eat, but to serve as compost for the fungus that truly sustains their entire colony. You can see them moving in endless, determined lines, forming living green rivers that flow across the forest floor and then disappear into the earth. Down in the darkness, specialized worker ants chew the leaf fragments into a soft pulp and then carefully seed this mulch with fungal spores. This growing fungus becomes the sole source of food for the colony, and the ants maintain its health with an astonishing and tender care. They methodically remove any contaminants, they regulate the humidity of the garden chambers, and they even use natural antibiotics, which are produced by specialized bacteria that they cultivate on their own bodies, to keep their crops free from disease. This incredible partnership, this symbiosis between ant and fungus, has existed for millions of years. A quiet and profound alliance between two different species that have come to depend entirely on each other for their survival. Deep underground, completely hidden from the light of the sun, they practice a form of agriculture that predates human civilization by an unimaginable span of time, cultivating life with a quiet precision and an unwavering devotion in the eternal darkness. From this image of patient cultivation, our path now leads us to one of nature's most chilling and masterful manipulations. The breathtaking beauty of the jewel wasp hides a chilling and absolute mastery of biology. When a female is ready to lay an egg, she seeks out a cockroach and delivers two of the most precise stings in the entire animal kingdom. The first sting, delivered to the body, paralyzes the prey's front legs, preventing its escape. The second sting is a feat of neurosurgery, aimed directly into a specific part of the cockroach's brain that controls its ability to initiate movement. This second sting does not paralyze, it removes the cockroach's will to act independently. The cockroach remains alive, able-bodied, but completely docile, a living puppet. The wasp can then lead it, like a pet on a leash, into a burrow. There she lays a single egg on its body and seals the entrance. When the larva hatches, it feeds on the living, unresisting host until the moment it is ready to emerge as a new, fully formed wasp. This gruesome, intricate cycle is both horrifying and utterly extraordinary in its surgical precision. Every movement, every chemical signal is perfectly and exquisitely tuned to ensure the continuation of the wasp's lineage. In the jewel wasp's luminous, shimmering body lies one of evolution's strangest and most unsettling masterpieces, a story that shows how life, in its quest for survival, can bend even consciousness itself to its will. From this dark miracle, we return to a gentler, more poetic mystery. The transformation of a butterfly is total, a complete dissolution and rebuilding of its form, and yet, somehow, memory survives. A natural male narrator voice, with a warm, friendly tone. The overall mood is relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.8. Scientific studies have shown that caterpillars that have been trained to associate a certain scent with a food reward will still respond to that very scent after their metamorphosis into a butterfly. During the chrysalis stage, their bodies almost completely dissolve into a nutrient-rich soup before being entirely rebuilt. Yet faint traces of their neural memory, of their lived experience, somehow remain intact. This incredible continuity connects their larval and their adult lives, forming a single unbroken thread of experience that crosses one of nature's most dramatic and absolute boundaries. It suggests that memory is somehow more resilient than physical form, that it can be carried within the very reorganization of the nervous system itself. To imagine a butterfly fluttering in the sun, recalling the faint, sweet taste of a leaf it once ate as a humble caterpillar, is to glimpse the profound persistence of self through even the most total and complete change. It is a living metaphor for continuity and for transformation, a gentle reminder that even in a complete and total rebirth, something of who we once were always and miraculously finds its way through to what we become. From the lingering memory of a butterfly, we now shrink our focus to a creature of immense power, a power contained within a body almost too small to see. Though they are tiny and wingless, fleas possess one of the most powerful and explosive leaps in the entire animal world. Their legs are not just levers of muscle, they are intricate biological springs. They store enormous amounts of energy in a specialized rubber-like protein called resilin. When this natural spring is released, it propels the flea upward with an astonishing and instantaneous force, sending it soaring more than 100 times its own body height in a single, silent bound. This incredible ability allows it to navigate the dense forest of a host's fur, to escape from immediate danger, or to move between animals with an effortless and startling ease. The precision of this jump is nearly as remarkable as its power, allowing the flea to land exactly where it intends. What we might perceive as a simple, irritating nuisance is, in truth, a mechanical and physical marvel, a perfect machine designed by evolution to turn muscle and elasticity into pure, explosive power. In the quiet, unseen motion of a single leap, there lies a profound physics lesson written by nature itself. A gentle proof that greatness, and indeed immense power, often hides in the smallest, the humblest, and the least celebrated forms of life. From this burst of contained energy, we now drift into the deep of night, into a world perceived not through leaps or bounds, but through the most delicate and invisible of signals. In the profound darkness, male moths navigate by following faint, ethereal messages that drift silently through the air. Females release chemical perfumes, known as pheromones, that can travel over astonishing distances, carried on the gentlest of breezes. Some species of male moth can detect a single, solitary molecule of this scent among billions and billions of other molecules in the air. Their magnificent feathery antennae are exquisitely tuned to this one specific chemical signature. These delicate, intricate sensors are covered in thousands of fine, sensitive hairs that capture the faintest, most fleeting traces of the fragrance. The overall mood, fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. Pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.8. Once the moth catches this invisible signal, he begins to follow it unerringly, flying in a characteristic zigzag pattern toward the source with an unwavering and absolute purpose. This breathtaking ability allows them to find a mate even across vast, sprawling landscapes, guided purely by the silent language of chemistry. To our senses, the night may seem silent and empty, but for the moths, it is filled with invisible, shimmering trails and whispered messages carried on the soft currents of the air. Their world is not built on sight nor on sound, but on scent and on pure, unyielding instinct. It is a sensory dimension that reminds us how much of life's most vital communication happens in ways our own senses can barely begin to imagine. From the solitary quest of the moth, we turn now to an act of incredible collective survival. When floodwaters begin to rise, fire ants do not drown, nor do they flee in chaos. Instead, they perform a miracle of cooperation. They cling tightly to one another, locking their legs and their mandibles together to create vast living rafts. These buoyant, floating structures can last for weeks, carrying the colony's precious queen and all of her larvae safely across the turbulent water. Each individual ant remains buoyant through the simple force of surface tension, and together they form a shifting, breathing island of life that constantly adjusts its shape as the conditions around it change. The unity is so absolute and so complete that the raft behaves like a single intelligent organism, responding collectively to waves, to obstacles, and to any potential threats. This incredible survival strategy has allowed fire ants to endure and to thrive in some of the harshest and most unpredictable environments on Earth. It is a vivid and powerful demonstration of perfect cooperation in the face of absolute disaster, showing how even the smallest of lives can achieve the seemingly impossible through connection and through trust. In their living boats, built from courage and from instinct, they embody the quiet, unshakable strength that comes only from perfect unity. And now, from the strength of the many, we journey to the very edge of what is possible, to the absolute limit of smallness. At the very edge of what the human eye can perceive, there lives the fairy fly, a tiny wasp so small that it drifts through the air like a single mote of living dust. Adults of some species measure less than 0.2 of a millimeter long, making them smaller than a single grain of common salt. Their wings are not solid planes, but are delicate, fringed with fine, long hairs that allow them to float and paddle through the air rather than beat against it. Despite their microscopic size, they are fully formed, complex insects, complete with eyes, antennae, and the ability to fly and to reproduce. Their entire life cycle unfolds on a scale that is almost beyond our comprehension. They lay their eggs inside the eggs of other larger insects, beginning a new life within a world that is itself barely visible. To imagine a complete and intricate life existing in such a miniature and delicate form is to begin to realize how truly vast and endlessly creative life really is. Even within the smallest, most forgotten spaces, evolution finds ample room for complexity, for purpose, and for a quiet, breathtaking grace. The fairy fly is a mere whisper of creation, a living proof that true wonder exists far, far beyond the narrow limits of our own sight. From the near invisibility of the fairy fly, we drift now to a creature known and loved for its vibrant visibility. Ladybugs may look gentle, symbols of good fortune and innocent summers, but they are armored with one of nature's most clever and effective defenses. When a ladybug is threatened, it exudes a yellowish, oily fluid from its delicate leg joints. This response, known as reflex bleeding, releases a liquid that smells and tastes deeply unpleasant to most predators. The oily secretion carries potent toxins that can strongly discourage a bird or a spider from ever taking another bite, creating a lasting and memorable lesson. The brilliant red and black pattern of a ladybug's wings is not for beauty alone. It is a warning, a universal symbol in the natural world that this creature is not worth the trouble. This visual language, known as apostomatism, is nature's stop sign, an honest signal that beauty can hide danger. Ladybugs spend much of their lives as quiet gardeners of our gardens, diligently feeding on aphids and saving crops from destruction. But when danger approaches, they become tiny, passive alchemists of survival. Their undeniable charm masks a quiet ferocity and a defensive chemistry that has been honed through millions of years of evolution. The next time you see one resting peacefully on a leaf, know that beneath those shining, perfect spots lives a tiny warrior, wrapped in both beauty and a potent defense. From this chemical defense, we now turn to a defense of pure illusion. The atlas moth, one of the largest and most magnificent insects in the world, carries upon its wings a perfect and startling deception. The very tips of its enormous forewings are patterned to resemble the head of a snake, complete with convincing eye-like patterns and curving, serpentine outlines. When the moth feels threatened, it flutters its wings in a slow, undulating way that makes this pattern come alive, startling and deterring birds and lizards that might otherwise have attacked. The moth's wingspan can stretch over 30 centimeters, a breathtaking expanse of dusty silk, yet it rarely flies far from where it emerged. As an adult, it has no mouth and is completely unable to eat, living for only a few precious days. Its entire brief, beautiful life is sustained by the energy it stored as a caterpillar. During that short final chapter, it relies entirely on its size, its grace, and the quiet, potent power of illusion. In the deep stillness of a tropical night, its broad wings unfurl like living silk lanterns, glowing faintly in the soft moonlight. The atlas moth reminds us that even life's very briefest moments can be lived with an incredible grandeur and a profound, lingering mystery. From the moth that mimics an earthly creature, we now journey to a creature that communes with the heavens. In the soft, profound darkness of the African plains, dung beetles perform a nightly act of celestial navigation that is nothing short of astonishing. After collecting their prize, a carefully sculpted ball of dung, they must roll it away in a perfectly straight line to escape the chaos and competition at the dung pile. For years, scientists were mystified as to how they maintained such a true course in the dead of night. They discovered, through remarkable experiments, that the beetles aligned their paths not by the moon or by earthly landmarks, but by the faint, shimmering glow of the Milky Way itself. Even when clouds obscure the individual stars, the faint, diffuse band of galactic light provides enough of a signal to guide them. The overall mood. The overall mood makes them the only known insects that use the vast tapestry of the stars for navigation. It is a humble yet deeply astonishing connection between one of the smallest of creatures and the utter vastness of the universe. The beetle, pushing its earthly burden beneath an endless ocean of starlight, becomes a silent symbol of perseverance and of a quiet, cosmic harmony, effortlessly bridging the immense distance between the earth and the sky. From this traveler of the open plains, we descend once more, deep into the hidden depths of a termite mound. Here lives a queen who may rule her kingdom for longer than many of the great trees outside will stand. Once she is fully mature, her body becomes a vessel of pure fertility. Her abdomen swells to an enormous size, filling with eggs until she is so large she can no longer move. Surrounded by a retinue of attendants, she spends her entire life in this sacred chamber, producing thousands of eggs every single day, ensuring the colony's constant and unwavering renewal. Some termite queens have been known to live for more than 20 and perhaps even up to 50 years, making them among the longest-lived insects on the entire planet. Her body pulses with the slow, steady rhythm of creation, each gentle beat bringing new life into the colony. She is endlessly tended, cleaned, and fed by her loyal workers, revered as the living, beating heart of their entire civilization. Outside her royal chambers, soldiers guard the mound, workers maintain the perfect airflow, and others repair the high clay walls. But within her, the future of millions begins and is sustained. She is both a monarch and a machine, a living embodiment of continuity, of persistence, and of the strange, enduring, and deeply mysterious logic of life underground. From the eternal darkness of the Queen's chamber, we journey now to the vibrant, humid world of the rainforest canopy. Here lives a creature named for its immense and legendary strength, the Hercules beetle. Yet it possesses another, far more subtle and astonishing trait. Its magnificent shell can change its color with the weather. In the dry, warm air of the day, it appears a soft, muted olive or a gentle yellow. But when the humidity rises, as the afternoon rains begin to fall, its shell darkens to a deep, lustrous green, or sometimes even to a glossy, polished black. This remarkable color shift is not caused by pigments, but by a complex architecture of microscopic structures within the beetle's shell. These structures form a porous, sponge-like layer that alters how light is reflected depending on the precise level of moisture in the air. This magical transformation may help with camouflage against the wet, dark leaves of the forest, or perhaps aid in temperature control in the dense, steamy jungles of Central and South America, where these gentle giants dwell. The males are renowned for their long, gracefully curved horns, which they use in dramatic and surprisingly slow-motion battles over mates, their powerful clashes echoing faintly through the thick green leaves. Beneath their incredible toughness, there lies a beauty that is both functional and deeply mysterious. The Hercules beetle is a creature of constant, quiet transformation. The overall mood of the canopy, our journey takes us down into the cool, silent world of water. Before they become the graceful, shimmering flyers that glide over sunlit ponds, dragonflies spend most of their lives underwater as larvae, known as nymphs. During this long, hidden stage, they breathe through gills. But these gills are located not on the outside of their bodies, but secreted away within their rectum. Water is gently drawn in and then pushed out, allowing oxygen to pass through hidden, delicate folds deep inside their bodies. This same remarkable mechanism can also be used for a form of jet propulsion. By shooting powerful bursts of water out from their rear, the larvae can propel themselves forward with a surprising and sudden speed, darting through the murky water to catch prey or escape danger. And in this secret aquatic life, they are fierce and patient hunters, devouring tadpoles, small fish, and other insects with a silent ferocity. For months, sometimes for years, they live completely unseen beneath the still surface of the water, patiently waiting for the day they will be called to climb a single reed and transform. When that moment arrives, they emerge from the water, leave behind their old larval skin like a ghost, and for the first time unfold their new crystalline wings, rising into the open air. The dragonfly's story is one of hidden strength, of a profound and total transformation, and of the deep, quiet patience that always precedes true brilliance. From this solitary life of transformation, we are now swept away by a force of nature that is pure, unified momentum. Deep in the lush, humid forests of the tropics, the army ants move not as individuals, but as a single, living river. A single colony can hold millions of individuals, each one performing its role in a perfect and terrifying coordination. They travel in vast, sprawling columns that sweep across the forest floor, a moving carpet of life that consumes almost everything in its path. They have no permanent nest, no single place they call home. Instead, when they rest, they form temporary bivouacs made entirely from their own living bodies, linking their legs and bodies together to create protective walls and hollow chambers that house and protect the queen and her precious brood. At night, the entire swarm folds in upon itself, becoming a breathing, sentient fortress. By dawn, it unravels once more, flowing forward again in a wave of silent collective hunger. The colony acts as a single massive organism, a collective mind driven by a deep and ancient instinct and an unbreakable unity. To witness their advance is to see a pulse of life that feels both ancient and utterly inevitable, a pure expression of nature's relentless, unyielding will to move, to feed, and to endure. And finally, from this image of overwhelming force, our journey concludes in a moment of the most surreal and gentle intimacy. In the humid, languid jungles of South America, butterflies can sometimes be found perched with a feather-light touch upon the faces of sleeping turtles, caimans, or even birds. They are not feeding on flesh or on blood. They are drinking tears. The overall mood provides them with vital nutrients, like sodium, that are scarce in their usual diet of nectar. With their delicate, coiled tongues, they sip the precious moisture without ever waking their hosts, creating one of the strangest and most tender exchanges in all of nature. Scientists call this behavior lacryphagy, the drinking of tears. It is an eerie yet poignant relationship, born from pure necessity rather than any form of cruelty. In the deep, quiet stillness of the rainforest, this soft communion between a potential predator and a delicate visitor becomes a moment of profound, surreal beauty. The butterfly's iridescent wings shimmer in the dim green light while it feeds, in a way, on sorrow itself, reminding us that even the act of nourishment can take the gentlest, the quietest, and the most unexpected of forms. A mosquito's world is a landscape mapped entirely in gradients of warmth. As it draws near to a potential host, its highly specialized sensory organs begin to detect tiny, almost infinitesimal differences in temperature across the skin surface. The gentle radiating heat of blood flowing just beneath the surface becomes a soft glowing beacon, a thermal landmark that guides its delicate proboscis with an unerring and surgical precision. Once it has landed, a touch so light it is almost never felt, the mosquito probes delicately, patiently, until it finds the perfect warm spot to feed. This remarkable and highly refined ability comes from specialized receptors located in its antenna and mouthparts, which respond not to visible light, but to the invisible waves of infrared radiation. This allows it to sense heat in much the same way that some snakes do, perceiving a living creature as a shimmering thermal aura against the cooler background of the night. The overall mood of biological engineering, a system that has been refined over millions upon millions of years. While we may only feel the sting as a minor irritation, the mosquito experiences a world sculpted in the invisible colors of heat, a world of scent, and a world of breath. In its silent, determined pursuit of blood, it follows the oldest and most fundamental rhythm of all life on Earth, the quiet, constant, and invisible exchange of energy between bodies, an eternal and unspoken dance. From this world of silent thermal perception, we now move into a world of overwhelming sound. In the deep, shimmering heat of summer, the very air itself vibrates with the call of the cicada, which produces one of the loudest and most penetrating sounds of any insect on the planet. Certain species can generate songs that reach over 100 decibels, a volume powerful enough to carry across vast fields and dense forests. The sound is not a voice. It is made by the rapid contractions of special muscles that flex and buckle thin, drum-like membranes on their abdomen called tymbals. This creates a resonant mechanical rhythm that is amplified by the hollow chambers of the insect's body. Each species has its own distinct and recognizable call, a unique acoustic signature used to attract mates or to mark its territory. When a chorus of thousands sing together, it creates a soundscape that can feel almost hypnotic, a deep, pervasive hum that seems to rise from the very ground itself, from the trees, from the sky. For the cicadas, this thunderous music is both a love song and a vital survival strategy, overwhelming predators through sheer, deafening volume and immense numbers. The overall mood of silence, the lives have lived entirely in the service of renewal, their individual voices joining in one vast, vibrating hymn to the warmth of the summer sun. From this deafening chorus, we retreat now into a world of profound silence and invisibility, where survival is found in stillness. Some species of walking sticks have evolved a remarkable and highly efficient form of reproduction known as parthenogenesis. The females of these species can produce viable offspring without ever mating, creating exact genetic copies of themselves, perfect little clones that continue the maternal line. In times when males are scarce or when environmental conditions are particularly harsh, this ability allows their populations to endure and to spread with quiet efficiency. Entire forests may be home to countless generations of nearly identical females, continuing a lineage that never needed a partner to thrive. And yet, when males do appear, sexual reproduction can resume, reintroducing genetic variation and adaptability back into the population. This incredible balance between cloning and diversity gives walking sticks a profound and understated resilience. They are already masters of invisibility, their bodies blending perfectly with the twigs and the leaves among which they live. But their hidden lives carry an even deeper lesson about survival. In their own quiet, unassuming way, they reveal how life will always find a method to continue, whether through union or through solitude, keeping the ancient rhythm of reproduction alive in the simplest, the quietest, and the most astonishing of forms. Though leafhoppers, too, appear to live in a world of silence, their reality is in fact filled with a constant stream of hidden music. Instead of producing sounds that are audible to our ears, they send tiny rhythmic vibrations through the plants they live on, communicating by rhythm rather than by tone. The overall mood should be relaxed, engaging, and comfortable, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.8. Using small specialized organs on their abdomen, they generate minute tremors that travel along the stems and the leaves, carrying complex messages about territory, about mating, or about the approach of danger. These vibrations are far too faint and subtle for human ears to ever detect. But with special equipment, a secret world is revealed. In the dense vegetation of a meadow, the air may seem perfectly still, yet the plants themselves are humming with this coded conversation. Leafhoppers rely on this intensely private language to survive, avoiding predators who cannot possibly hear their silent messages. It is a symphony of touch rather than one of sound, a gentle reminder that life speaks in countless voices that exist just beyond our own perception. The next time you watch the wind stir the tall grass, you might imagine 1,000 tiny, unseen instruments playing within it, unheard by us, but endlessly expressive. Finally, from this hidden music, we drift to a life that is a study in pure impermanence. The mayfly's existence is a poignant poem of timing. After spending months or sometimes even years living underwater as a larva, feeding and growing in the slow, dark currents, it emerges into the air as an adult with only one singular purpose: to reproduce. In its beautiful, winged adult form, it has no mouth, no stomach, and no need for food. Within just a few hours, sometimes in less than a single day, it will find a mate, lay its eggs upon the water, and then, its purpose fulfilled, it will die. For a brief, magical time, the air around rivers and lakes becomes filled with their fragile, translucent wings, fluttering in great, silent clouds of golden light as the sun begins to set. To our human eyes, such a brief existence may seem tragic, but in the grand, unhurried rhythm of nature, it is a form of perfect timing. Each fleeting generation ensures the survival of the next, continuing a cycle that has endured for more than 300 million years. The mayfly's ephemeral, beautiful existence reminds us that beauty and transience often and gently walk hand in hand. In its short, silent flight, it lives an entire lifetime, one that ends just where it began, beside the quiet, reflective water. Among the sun-scorched desert sands of North America, in a world of harsh, unrelenting extremes, there lives a creature of almost unbelievable endurance, the diabolical ironclad beetle. Its exoskeleton is so profoundly tough, so perfectly engineered for resilience, that it can survive being run over by a car without suffering any injury. The secret to its incredible strength lies in the intricate, interlocking design of its shell. The two halves of its elytra, or wing covers, are not fused into a single piece, but are joined together by a series of complex, layered sutures that fit together like an elaborate three-dimensional jigsaw puzzle. This natural marvel of engineering allows the shell to distribute any crushing pressure evenly across its entire body, preventing catastrophic fractures. This natural armor allows it to resist forces that would destroy almost any other insect, and indeed many larger creatures as well. Scientists and engineers, in their quest to build stronger and lighter materials, have studied its structure with a sense of awe, drawing inspiration for developing more durable materials for aircraft, for buildings, and for protective gear. The overall mood and dramatic name, the beetle itself feeds mostly on fungi and the quiet, decaying plant matter it finds beneath bark and leaf litter, living a slow and unassuming life. Its incredible strength is not used for aggression, but for pure, passive defense. It is a quiet, living reminder that true resilience often lies not in the attack, but in the unseen, internal architecture of survival. From this fortress of an insect, we return to the termite mound, which is not a fortress of defense, but a marvel of environmental engineering. A termite mound may appear to be a simple, static pile of earth, yet it is a dynamic, living lung, a masterpiece of climate control. Inside its thick walls, the temperature and the humidity remain almost perfectly constant, year-round, regardless of the scorching heat or sudden cool of the world outside. Termites achieve this incredible feat by constructing an intricate and ever-changing network of tunnels and vents that directs the flow of air through the entire structure. As the warm, stale air from the colony's collective breath and activity rises through a central chimney, cooler, fresh air is drawn in from vents located at the base of the mound, creating a self-regulating passive circulation system. Some species in Africa have even evolved to build their mounds with a distinct north-south orientation, shaping them into tall, flattened blades that capture the sun's warmth on their broad faces in the cool morning and evening, while presenting only a thin edge to the intense heat of the midday sun. This living, breathing architecture allows the colony's delicate subterranean fungus gardens, their sole source of food, to thrive in a perfectly controlled environment. Engineers in a warm, friendly tone, fluid and easy to follow, like a light science podcast. Keep your voice clear and coherent, with a gentle intonation that is both intelligent and soothing. Use pauses when necessary. The overall mood should be relaxed, engaging, and comfortable, perfect for bedtime reading and space narration. The tempo should be around 0.8. Engineers and architects have studied these mounds for decades, seeking to design buildings that can cool themselves naturally, without the need for electricity. What appears to us as simple, blind instinct is in fact a form of profound wisdom encoded in the slow, patient language of evolution, transforming these simple, tiny creatures into the silent masters of sustainable, living design. From this mastery of the physical world, we now drift into a world of perception, where reality itself is painted in hues that lie beyond our human comprehension. To a butterfly, the world is a tapestry of colors we cannot even begin to imagine. Their magnificent compound eyes can perceive ultraviolet light, allowing them to see a secret, hidden layer of patterns on flowers that guide them directly to the nectar within. What appears to us as a plain white petal may to them glow with intricate invisible markings, with nectar guides and landing strips painted in a light we will never see. Different species can see slightly different ranges of color, and some can even perceive the polarization of light itself, using the patterns of the sky to navigate. Their vision fundamentally shapes how they move through the world, how they recognize potential mates, and how they experience the very landscape around them. The shimmering, iridescent brilliance of their wings often mirrors the incredible richness of their perception, with each flash of color serving as a reflection of how they see. In the soft, gentle light of the morning, a butterfly flutters not just through a world of color, but through a world of wavelengths that exist completely outside our own senses. The overall is a quiet, beautiful reminder that beauty is not limited to what we can perceive. and that reality is far more colorful, far more complex than our own vision can ever possibly reveal. Now, from this world of hidden beauty, we must turn to a creature that has, despite its small size, shaped the fate of entire civilizations. Mosquitoes are, by a staggering margin, among the deadliest animals in all of human history. By carrying and transmitting diseases such as malaria, yellow fever, and dengue fever, they have been responsible for more human deaths than any other creature in our recorded history. The course of human events has been altered by their tiny bites. Ancient armies were weakened and turned back by them. Great expeditions were delayed and defeated, and the fates of empires were sometimes decided by the relentless, invisible spread of illness that they carried. The female mosquito, needing a meal of blood to nourish her eggs, becomes an unwitting and impartial messenger of pathogens. And yet, mosquitoes also play a vital, if often unappreciated, role in their native ecosystems. They serve as important pollinators for certain plants, and they are a crucial food source for countless species of fish, birds, bats, and other insects. Their story is one of profound balance and of immense consequence, a story of how even the smallest and most fragile of lives can tip the grand scales of history. In the soft, high-pitched hum of their wings, there lies both menace and a strange ecological meaning, a reminder that true power is not measured in size, but in pure, unwavering influence, written across time in the quiet, persistent language of flight. And from this creature that thrives in the lushest environments, we journey to a place where life itself should not exist. Here, in the shadow of destruction, certain beetles thrive. After a volcano erupts, when the ash still smolders and the entire landscape is a blanket of sterile gray, these tiny pioneers are among the very first to arrive. They burrow into the cooling, nutrient-poor soil, feeding on whatever scant organic matter may have survived. Their bodies are perfectly adapted to the intense heat and the profound dryness, with shells that reflect the harsh sunlight and physiological systems that conserve every precious drop of moisture. Over time, their quiet, unseen work helps to transform this sterile ground back into living soil. They break down minerals, and their burrowing creates pathways for air, water, and, eventually, for the roots of plants to take hold once again. In this way, they are among the very first engineers of renewal in the wake of total destruction. Their humble presence marks the true beginning of recovery, the first faint pulse of life returning to a wounded and silent world. These beetles carry within them the very spirit of resilience, quietly showing that even in the deep shadow of fire and destruction, nature will always and patiently find a way to rebuild and to begin again. The assassin bug lives a life of profound stealth and chilling precision. It hides in plain sight among the intricate patterns of leaves or the rough texture of bark, its own body shaped and colored to completely vanish into the background. It is a creature of pure patience, waiting in a state of meditative stillness for the world to come to it. When its unsuspecting prey passes close by, it strikes with a speed that is almost faster than thought, using a sharp, needle-like beak to inject a potent cocktail of enzymes. These enzymes liquefy the victim from within, a silent and internal process of dissolution. The assassin bug then quietly drinks the fluid, leaving behind nothing more than a hollow, empty shell, a fragile monument to a life that is past. Some species take this art of deception even further, using the desiccated carcasses of their previous victims as a form of macabre camouflage, wearing them as a shield of armor against their own potential predators. Their methods are ruthlessly efficient, deeply calculated, and unsettlingly intelligent. Yet, despite their fearsome and predatory nature, assassin bugs play a crucial and stabilizing ecological role. They control the populations of many pest insects, maintaining a delicate and vital balance within their habitats. Each silent ambush they carry out is a quiet act of equilibrium, a necessary and impartial exchange within the intricate food web. In their profound stillness and their unerring precision lies the pure, dispassionate artistry of the hunter, a quiet reminder that nature's most elegant and effective strategies are often its most silent and unseen. From this master of the present moment, we now drift back, far back, into the deep, ancient corridors of time. Long before the first dinosaurs ever walked the earth, cockroaches were already thriving. Fossil evidence shows that their earliest ancestors lived more than 300 million years ago, scurrying silently beneath the giant ferns and towering horsetail plants of primordial swampy forests. Through countless ice ages, through devastating meteor impacts, and through the slow, grinding rise and fall of entire continents, they have quietly, simply endured. Their adaptability is virtually unmatched in the entire story of life. They can survive without food for weeks on end. They can withstand levels of radiation that would be instantly fatal to humans. And they can squeeze their soft bodies through gaps that are thinner than a coin. Each time the world has changed, they have changed with it, outlasting countless other species that were larger, stronger, and seemingly more powerful. Though they are often reviled in our modern world, the cockroach is a true and living symbol of persistence, a testament to evolution's quiet genius for sheer endurance. In every dark corner and every forgotten dusty space, they continue a lineage that is older than mammals, older than reptiles, and older than the first birds that ever took to the sky. They are living fossils, animated by a purpose that whispers of the planet's most ancient and truly unbroken story. From this ancient silence, we now attune our ears to an equally ancient sound. In the quiet, lingering warmth of the night, the gentle song of a cricket drifts softly through the tall grass. That familiar, soothing chirping is not a voice. It is the sound of wings scraping together in a perfect and practiced rhythm. Male crickets produce their serene song by rubbing a sharp, hardened ridge on one wing against a file-like surface on the other, creating a clear, resonant vibration that carries beautifully through the still air. Each species of cricket sings in its own unique pattern, its own distinct tempo. Some chirps are quick and steady, a constant, reassuring pulse. Others are slow and melodic, rising and falling like a gentle sigh. This sound serves as both a heartfelt invitation and a subtle competition, a call to potential mates hidden in the darkness, while at the same time warning rivals to keep their distance. A female cricket listens closely, her future choices guided by the most precise and unwavering rhythm, which she perceives as the truest sign of health and of strength. To our human ears, the cricket song brings a sense of calm and a deep nostalgia, a sound that has become the very heartbeat of warm summer evenings. Yet to the crickets themselves, it is a complex and vital language of longing, of connection, and of the timeless, universal music of survival. From this gentle serenade, we must now turn to a story that is far more haunting. Among the many astonishing strategies in nature, few are as eerie as that of the parasitic wasp that enslaves spiders. The female wasp seeks out a specific host, stings it with a pinpoint and surgical accuracy, and then lays a single egg upon its back. The spider continues to live, seemingly unharmed by the encounter. But the growing larva on its back begins to release powerful chemicals that slowly and inexorably alter the spider's behavior, hijacking its very mind. When the time is right, the spider, under the larva's silent command, abandons its normal, intricate web building and begins to construct a special, heavily reinforced structure unlike any it has ever spun before. This new, strange web will serve as a protective cradle for the wasp's cocoon. The overall mood of unsettling and perfect precision. A light science podcast. Once this final, eerie structure is complete, its purpose served, the larva kills its host and takes its place in the very web it forced the spider into being. It is a story of unsettling and perfect precision, of instinct and of control interwoven in biology's darker and more mysterious poetry. Within this grim and silent choreography lies a stark reminder that evolution, in its impartiality, creates both breathtaking beauty and a chilling cruelty, often within the same delicate, shimmering form. And now, from that darkness, we rise into a soft and gentle light. In certain magical tropical nights, entire forests seem to breathe with a silent, synchronized glow. Thousands upon thousands of fireflies gather in the trees, their individual flashes pulsing together in a perfect and mesmerizing harmony. Scientists believe this breathtaking synchronization is a form of amplified communication, a collective shout that allows males and females to find each other amidst the vast, overwhelming darkness. Each tiny lantern glows through a cool chemical reaction between oxygen and luciferin inside its abdomen, producing a pure, gentle light without any heat. When this silent rhythm spreads across the trees from one firefly to the next, the forest becomes a living constellation, a terrestrial and breathing mirror of the silent, starry sky above. In some regions, these sacred gatherings have been celebrated by humans for centuries as profound natural wonders. The sheer precision of the timing remains partly mysterious, a form of collective awareness that seems almost telepathic in its perfection. For a few precious, fleeting moments, the entire forest becomes a single glowing organism, breathing in a slow, silent, and perfect unity. The synchronized light of the fireflies is nature's quiet, unassuming symphony. A gentle proof that a profound and breathtaking beauty can arise from the simplest, most delicate sparks of life. In the warm, humid air of the tropics, we now encounter a living illusion, a creature of such perfect and breathtaking beauty that it seems to have been sculpted from a dream. The orchid mantis is a masterpiece of deception and grace. Its pale pink and white body, with its delicate lobed legs, perfectly imitates the soft, inviting petals of tropical blossoms. Resting quietly among real orchids, it becomes utterly indistinguishable from them, a living flower among the real ones, waiting with a profound and unnerving patience for unsuspecting insects to draw near. Butterflies and bees, attracted by what appears to be a rich source of nectar, instead become a part of the mantis's silent, unhurried feast. Even the way it moves, a gentle, almost imperceptible swaying, perfectly mimics the motion of a flower petal trembling in a soft breeze. Its disguise is so flawless, so utterly convincing, that early naturalists who first encountered it mistook its form for a strange kind of plant adaptation rather than an animal's camouflage. This living work of art shows how deeply and intricately evolution can sculpt both form and behavior together, weaving them into a single, seamless strategy for survival. The orchid mantis does not need to chase its prey. It simply waits, still and radiant, until life, in all its innocence, comes directly to it. In its quiet, beautiful deception, there lies a beauty that is at once serene and utterly ruthless, a perfect and living art of survival, painted in the soft, gentle colors of life itself. From this image of solitary, beautiful cunning, we now journey to a world where survival is not an individual art, but a collective and sometimes tragic sacrifice. In the dense, ancient rainforests of Southeast Asia, some species of ant possess a form of defense unlike any other in the known world. When their colony is threatened by an intruder, specialized worker ants perform an act of ultimate devotion. They intentionally and violently rupture their own bodies, releasing a sticky, toxic fluid that instantly immobilizes their enemies. The act is, of course, instantly fatal to the ant, yet it saves the colony. These self-destructive soldiers are the ultimate defenders, their individual lives woven into the very fabric of their society as a final, desperate strategy. Each tiny explosion releases chemicals so potent they can repel or kill much larger predators. Scientists have given this incredible adaptation a name, autothysis, a word that literally means self-sacrifice. It is a striking and poignant example of how far nature's designs can go in the service of the community. Within the unified mind of the colony, every individual is merely a part of something much, much larger, and the survival of the group will always outweigh the survival of the self. Their story is both tragic and deeply awe-inspiring, a quiet testament to the profound depth of cooperation and devotion that can exist in even the smallest and most humble forms of life. From this act of explosive sacrifice, we turn to a sense that is almost impossibly delicate. While butterflies are known and celebrated for their vibrant color and their silent, weightless grace, they also possess an unexpected and hidden sense of hearing. The overall mood of the thin, fragile membranes of their wings are specialized, nerve-rich structures that can detect subtle sound vibrations in the air. These tiny drum-like organs, called tympanal membranes, allow butterflies to sense the approach of predators, such as the flutter of a bird's wings or the high-frequency clicks of a hunting bat. The vibrations travel through the delicate, veined tissue of the wing like silent ripples across the surface of a still pond, giving the butterfly a form of early warning system. Some species respond to these sounds by immediately altering their flight pattern, darting erratically and unpredictably through the air to evade capture. Others rely on this sense to remain perfectly still when danger passes nearby, their trust placed in their camouflage. The discovery of wing-based hearing has completely changed how scientists understand these ethereal insects, revealing that their magnificent wings are not only for the poetry of movement and the language of color, but also for a deep and constant awareness of the world around them. Every silent, gentle flutter is part of a much larger sensory world, a world where sound, color, and motion merge in a perfect silent harmony beneath the vast open sky. We have spoken of the diabolical ironclad beetle's incredible resilience, a strength born of its unique interlocking armor. Let us revisit this marvel, for it deserves a second, quieter look. In the arid, sun-beaten deserts of California and the surrounding regions, there lives a beetle so profoundly tough that it can withstand the crushing weight of a passing car. Known to science as Phloiodes diabolicus, its common name, the diabolical ironclad beetle, feels more fitting for its near-supernatural endurance. Its exoskeleton is built not like a simple shell, but like a sophisticated, layered suit of natural armor. composed of intricately interlocking sections that distribute force across its entire body with masterful efficiency. This complex, puzzle-like design prevents cracks from forming and spreading, allowing the beetle to survive crushing pressures that would instantly destroy nearly any other creature of its size. Scientists studying its remarkable structure have found a deep well of inspiration for new engineering materials, from stronger and lighter aircraft shells to more effective protective gear for humans. Yet despite its formidable and almost indestructible defense, the beetle itself lives a slow and peaceful life, feeding quietly on fungi and the decaying wood it finds in its arid home. Its profound power lies not in aggression, but in a quiet, passive endurance. Within its small, unassuming, and slow-moving body, there exists a design perfected by millions of years of evolutionary pressure. It is a living masterpiece of natural architecture, a quiet and humble proof that true resilience can be as elegant and as intricate as it is overwhelmingly strong. From this incredible toughness, we now take to the air, to celebrate the very first pioneers of flight. Long before the first bird soared, before bats claimed the twilight, and eons before humans ever dreamed of lifting from the ground, it was the insects that first claimed the vast open skies. Around 400 million years ago, in a world of giant ferns and steamy primitive forests, they developed the miracle of wings, unlocking an entirely new dimension of existence. The very first flyers were likely small, clumsy, and primitive by today's standards. Yet their discovery of flight was a momentous event that utterly transformed the course of life on Earth. The overall movement of powered movement is a story written in the delicate, veined language of wings. And just as they were the first to fly, they were also among the first to fill the air with song. The gentle, rhythmic trill of a grasshopper on a warm, lazy afternoon is a sound that is older than human civilization itself. These soft, pastoral songs are created not by a voice, but by a simple and beautiful act of friction. The grasshopper rubs a roughened, file-like ridge on its long hind legs against the hardened edge of its wings, producing a series of clear, rhythmic vibrations that we perceive as a song. Each species has its own particular pattern, its own tempo and rhythm, a unique acoustic code that identifies individuals and serves to attract mates across the warm, sunlit meadows. The overall mood of peaceful, engaging, and comfortable, perfect for bedtime reading and space narration. The pace of their song is intimately linked to the temperature of the air, so much so that by counting the number of chirps in a given time, one can make a surprisingly accurate estimate of the warmth of the day. The sound fills the fields and the grasslands like a living, breathing pulse of summer itself. To other grasshoppers, this is not music, but a clear and vital form of communication. To us, it has become the very soundtrack of peaceful, sun-drenched days. Beneath this simple, rustic rhythm lies a profound lesson in the physics of sound production, an ancient and gentle melody carried on the air through the simple interaction of legs, wings, and the warmth of the sunlight. The grasshopper's song is a quiet conversation between a creature and its world, woven softly and endlessly through the deep, shimmering heat of the day. Beneath the gentle, golden hum of their collective work, bees hide a spark of intelligence so subtle and so profound that it continues to surprise the scientists who study them. Recent and remarkable studies have shown that honeybees can understand basic and abstract mathematical concepts, including the ideas of addition and subtraction. Using simple, color-coded symbols during carefully designed experiments, bees were taught to associate certain patterns with either increasing or decreasing the quantity of shapes they were shown. After a period of learning, they could then successfully apply that abstract logic to new and unfamiliar problems, consistently choosing the correct solution in order to earn a small, sweet reward of sugar water. This astonishing ability suggests that their tiny brains, smaller than a grain of rice, can process numbers and concepts in a way that was once thought to be limited to much larger and more complex animals. Beyond this simple arithmetic, we know that bees can recognize the abstract concept of symmetry. They can learn new tasks by observing other bees, and they can remember the precise location of countless individual flowers across miles of terrain. Within the deep, fragrant darkness of the hive, they perform their famous waggle dance, a physical expression that turns abstract numbers, distance, and angles into a living, kinetic geometry. The quiet, unassuming honeybee reminds us that intelligence does not require a large size, only a sufficient structure, a natural curiosity, and the quiet, unwavering persistence of learning. From this complex intelligence, we now turn to a form of life that thrives through a startling and profound simplicity. Aphids, the small sap-feeding insects often found in quiet garden clusters, possess one of nature's most efficient and streamlined reproductive systems. Many species have perfected the art of giving birth to live young without the need for mating, a process known as parthenogenesis. Deep within their translucent bodies, developing embryos grow as perfect clones of their mother, ready to begin feeding the very moment they are born. In the warm, abundant seasons of spring and summer, their populations can multiply with an almost unbelievable speed, covering entire plants in a matter of days. Some species of aphid are even born already pregnant, carrying the next generation within them before they have even taken their own first sip of sap. Then, as conditions change, as the days grow shorter and cooler, males will suddenly appear, and the cycle of sexual reproduction will resume, restoring genetic diversity to the population in preparation for the hardships of winter. This incredibly flexible life cycle ensures their survival through both times of great abundance and times of hardship. Aphids may appear fragile and vulnerable, but their life strategy reveals a quiet brilliance in its pure, unadorned simplicity. Through this patient rhythm of self-replication and perfect timing, they turn their vulnerability into a resounding success, thriving quietly across fields and gardens as one of the planet's most persistent, gentle, and adaptable forms of life. Anyone who has ever sat outdoors on a warm summer evening knows from personal experience that mosquitoes do not treat all humans equally. Some people seem to attract far more bites than others, and modern science has finally begun to uncover the elegant chemistry behind this preference. Mosquitoes are drawn to us by a complex and alluring cocktail of signals. The carbon dioxide we exhale, the gentle warmth of our bodies, and the specific, unique chemical compounds found in our sweat and the oils on our skin. Genetic factors play a significant role in determining these personal scents, meaning that your individual body chemistry dictates how appealing you smell to a nearby mosquito. People with higher metabolic rates or those with certain blood types tend to emit more carbon dioxide, making them easier targets to locate. Even the color of your clothing can play a role, with darker fabrics absorbing more heat and making you stand out as a warmer beacon in the cool evening air. These tiny, delicate hunters navigate through a world of invisible trails of scent, heat, and breath, guided by instincts that have been refined and perfected over millions of years. Their choices may seem random and unfair to us, but in the silent, invisible language of chemistry, each human being is a unique and distinct signal in the vast darkness of the night. The overall moths are gentle visitors of the night, feeding on the sweet nectar of flowers. A few rare species have evolved a much darker and more surprising habit. These nocturnal creatures have developed the ability to pierce the skin of sleeping mammals, including, on rare occasions, humans, to drink small amounts of their blood. Their specialized mouthparts, their proboscises, are hardened and strong enough to penetrate flesh, often without causing enough pain to wake their slumbering host. Scientists believe this unsettling adaptation may have begun as a way to extract vital minerals from animal tears or other bodily fluids, eventually shifting over evolutionary time toward direct blood feeding. Unlike mosquitoes, these moths are not known to transmit any diseases, but their behavior adds a strange Gothic twist to the gentle and dusty reputation of their kind. In the deep, profound stillness of the night, their soft wings flutter silently as they draw their sustenance from living hosts, completing a cycle that is both eerie and utterly fascinating. The image of a blood-drinking moth is a quiet reminder that even the most delicate and seemingly innocent forms of life carry deep and ancient secrets, shaped by pure need, by raw instinct, and by the endless, startling inventiveness of evolution. Finally, from this image of a gentle piercing, we turn to a pain that is legendary. In the lush green rainforests of Central and South America lives the bullet ant, a creature both feared and deeply revered for the power of its sting. The pain it delivers is said to be so immediate and so overwhelming that it has been compared to the trauma of being shot, a clean, white-hot, and blinding agony. The intense burning sensation can last for hours, throbbing with a relentless and consuming fire. The venom contains powerful neurotoxins that overload the body's pain receptors, creating a sensation that few living things could ever forget. Some indigenous tribes have historically used bullet ants in their initiation rituals, weaving dozens of them into gloves made of leaves that young warriors would wear to prove their endurance and their courage. And yet, despite their fearsome and formidable defense, bullet ants are not naturally aggressive creatures unless they are provoked or their colony is threatened. They live in highly organized colonies, tending to their larvae and gathering food with a quiet and steady diligence. Their sting is not an act of malice or of cruelty, but a powerful and unambiguous message of survival. The bullet ant perfectly embodies the profound duality of nature, a world where sublime beauty and terrifying danger often coexist, and where the smallest of creatures can command both our deepest awe and our most profound respect. The overall mood to the world alone. The tsetse fly of sub-Saharan Africa practices a form of motherhood that is remarkably familiar. She gives birth to live young. Deep inside the mother's body, a single larva grows in a protected, womb-like space, nourished not by a yolk, but by a special milk-like secretion produced by her glands. When the larva has grown large and strong enough, it is born, and it immediately burrows into the soft ground to begin its pupation. This unique and resource-intensive form of reproduction, known as adenotrophic viviparity, is exceedingly rare among insects and is astonishingly similar to mammalian birth. The tsetse fly invests heavily and personally in each of its offspring, producing only a few during her entire lifetime, but ensuring that each one has a very strong chance of survival. While these flies play a complex and ancient role in their native ecosystems, they are also infamous for their role in spreading sleeping sickness among humans and livestock. Yet their unique and gentle reproductive strategy reveals a surprising tenderness amid their fearsome reputation. It is a small, quiet miracle of direct nourishment and dedicated care, hidden within a creature often seen only as a pest or a vector of disease. From this hidden act of motherhood, we return to the great, vibrant chorus of the summer. When the air hums with a sound so pervasive it feels like the very voice of the season, it is often the song of the cicada. The males produce their distinctive, piercing calls using specialized drum-like structures called tymbals located on the sides of their abdomen. Powerful muscles contract and release these thin, ribbed membranes hundreds of times per second, and the resulting sound is amplified by the hollow, resonant chambers inside the insect's body. Each species sings its own unique rhythm, a distinct acoustic fingerprint that creates a layered, hypnotic chorus that can fill entire forests with its energy. In some cicada emergences, the sheer volume of their collective song can exceed 100 decibels, making it louder than many rock concerts. These powerful, pulsating songs are love calls, broadcast with an urgent intensity to attract the silent females hidden among the trees. To our ears, they are simply the soundtrack of intense heat and bright, hazy sunlight, a physical reminder of the Earth's deep seasonal pulse. But in each tiny, powerful vibration lies an ancient story of longing and of profound persistence. The story of creatures who have waited patiently for years underground, only to spend their brief, glorious time in the sun, filling the air with their music before they fade back into the eternal silence. From the deafening sound of the air, we now descend into the cool, silent world of water. Certain beetles live as comfortably beneath the surface of ponds and slow-moving streams as they do on land, thanks to an ingenious and beautiful adaptation. When they dive, they trap a shimmering bubble of air beneath their hard wing covers or among a dense field of fine water-repellent hairs on their bodies. This bubble acts as a miniature portable scuba tank, supplying the beetle with a constant source of oxygen while it is submerged. But it is more clever than a simple tank. The bubble also functions as a physical gill. As the beetle uses up the oxygen in the bubble, the partial pressure of oxygen inside drops, causing new oxygen from the surrounding water to diffuse into the bubble, while the waste carbon dioxide diffuses out. This slow, passive exchange can sustain the beetle for long periods, sometimes for hours at a time. These aquatic beetles glide gracefully through the sun-dappled water, hunting for small aquatic creatures and feeding on detritus. Their shimmering silver air bubbles glint like tiny, perfect mirrors, reflecting the light of the sun and the green of the leaves through the quiet water. They are a quiet reminder that even the smallest forms of life have mastered the art of invention, adapting perfectly to worlds where the simple act of breathing becomes a matter of elegant physical design. From the solitary diver, we return once more to the collective mind of the ant. To the human eye, the path of a single ant may seem random and chaotic, yet it is following a carefully mapped and invisible world of scent. As ants move, they leave behind faint, invisible chemical trails made of powerful substances called pheromones. Other ants can detect these minute traces with their highly sensitive antennae, following them with precision to rich food sources or back to the safety of the nest. The more ants that travel along the same route, the stronger and more attractive the scent becomes, reinforcing the trail and creating a bustling, invisible highway. If an established trail fades or is broken, new routes are quickly and efficiently formed, demonstrating a remarkable and fluid collective intelligence. This elegant system allows entire colonies to coordinate complex foraging patterns over vast areas without any single leader, guided only by the silent, democratic language of chemistry and by ancient instinct. To an ant, the world is painted not in colors but in smells. It is a constantly shifting network of invisible roads and signposts. Their perfect, silent coordination reveals how complex communication can exist in complete silence, connecting millions of individual lives through a language that is as powerful as it is ephemeral, a language that can vanish with a simple gust of wind. In the cold, mist-shrouded mountains of New Zealand, a land of ancient ferns and deep, silent forests, the weta endures conditions that would mean certain death for most other insects. During the harsh, freezing winter, it does not seek shelter or generate warmth. Instead, it allows its entire body to freeze completely solid. Ice crystals form in the fluid between its cells, but not within them, thanks to special miraculous proteins in its blood that prevent the formation of internal cell-shattering ice. In this state of suspended animation, its heart stops beating, its brain activity ceases, and it becomes a tiny frozen statue, a creature caught between life and death. And then, as the gentle warmth of spring returns and the temperatures begin to rise, the weta thaws, and slowly, miraculously, it resumes its life as if nothing at all had happened. This incredible survival mechanism makes it one of nature's true miracles of profound endurance. The giant weta, which is among the heaviest insects on the entire earth, lives a slow, quiet, and ancient life, feeding on leaves under the soft glow of the moonlight. Its astounding ability to withstand being completely frozen demonstrates nature's infinite and startling creativity in the face of absolute hardship. In its profound, icy stillness, preserved by the winter's cold, the weta becomes a living symbol of patience and of deep, unwavering resilience. When the spring returns, so does its quiet, deliberate motion, a living proof that even in the still, frozen heart of winter, life waits softly, patiently for the warmth to come again. From this image of frozen endurance, we now take to the open air, to witness a journey that seems impossible for such a delicate and fragile creature. Some species of butterfly undertake epic migrations that defy all logic. Species like the painted lady and the iconic monarch have been observed crossing entire oceans, carried on the high, steady winds that span the continents. These incredible journeys can stretch for thousands upon thousands of miles, with successive generations continuing the voyage long after the first travelers have passed on. Scientists have tracked these butterflies flying from the heart of Africa to the shores of Europe, and even across vast, unbroken stretches of the Atlantic Ocean. Their paper-thin wings, which seem so impossibly fragile, are in fact perfectly and beautifully designed to catch the high air currents and to glide with an astonishing and effortless efficiency. Along their immense and perilous way, they feed, they breed, and they rest, guided by the invisible, powerful architecture of the air. Each migration is both a single heroic journey and an ancient, unbroken legacy, a living chain connecting faraway lands through the most delicate and beautiful persistence. In every silent, hopeful flutter over the vast open water, these butterflies embody a quiet courage, written in the universal language of color and of motion. They are drifters between worlds, with nothing but an ancient, encoded instinct, the warmth of the sunlight, and the steady hand of the wind to guide them home. From these visible travelers, we now turn our focus back beneath the surface of the earth to a hidden population so immense, so sprawling, that its total weight, its sheer biomass, may exceed that of every single human being on the planet combined. The termites, though individually tiny, exist in a population of countless, unimaginable billions, thriving across the world's forests, savannas, and deserts. Together, they form a vast subterranean network of life that is constantly, tirelessly rebuilding the very soil beneath our feet. By breaking down dead wood, fallen leaves, and other tough organic matter, they release vital, life-giving nutrients that nourish entire ecosystems. Each individual colony acts as a silent, living engine of renewal, patiently recycling the dead back into the living. In many tropical regions, their magnificent mounds can rise taller than people, and the number of individual workers inside a single one of these structures can reach into the millions. Their collective, ceaseless labor shapes entire landscapes, influences the global carbon cycle, and supports the growth of plants on a planetary scale. Though they are almost entirely unseen, the world beneath our feet hums with their endless, purposeful motion. They are a quiet and ancient civilization of builders, a society that outnumbers and, in its collective weight, likely outweighs our own. And just as their societies are complex, so too are the minds of their distant relatives, the bees. The honeybee, so well known for its perfect order and its selfless cooperation, also possesses a refined and surprising sense of beauty. Scientists have discovered that bees can recognize and remember symmetrical patterns, consistently showing a preference for balanced, harmonious shapes over chaotic or unbalanced ones. The overall mood of scent and of sound, but also one of pure form and of deep structural harmony. Their tiny compound eyes perceive a profound order where we might only see simplicity, revealing that even in the smallest of minds, the concepts of beauty and of function are deeply and inextricably entwined. In the strange silent theater of evolution, where the stage is often a single leaf or a drop of water, some flies have turned snails into living, breathing nurseries. In the quiet, damp corners of ponds and marshes, the female marsh fly seeks out a specific species of snail and deposits her eggs with a gentle touch inside its soft, vulnerable body, right through the opening of its shell. The tiny larvae hatch within this living vessel, and they begin to feed, slowly, with an innate and chilling patience, from the inside. They instinctively consume non-essential tissues first, keeping their host alive for as long as possible, ensuring that the snail continues to serve as a protective mobile shelter. When the larvae have grown and are finally ready to pupate, they break through the snail's delicate shell and crawl out into the world, leaving behind only the hollow, empty remnant of their first home. This eerie, silent process unfolds in the deep, quiet mud of the wetlands, a haunting reminder of how intricate and how utterly unsettling nature's strategies for survival can be. Each new life begins precisely where another one ends, a perfect and impartial balance of creation and destruction that has played out for millions upon millions of years in the quiet, forgotten corners of the world. From this world of internal patience, we return to a creature of external, calculated precision. Among all insects, the praying mantis stands almost entirely alone in its remarkable ability to perceive the world in true stereoscopic depth. Like humans, it uses stereoscopic vision, seamlessly combining the slightly different images from both of its large compound eyes to judge distance with incredible accuracy. This remarkable adaptation is the secret to its legendary hunting prowess, allowing the mantis to strike its prey with a perfect and unwavering accuracy, timing its attack down to the fraction of a single second. Its unique triangular head can swivel nearly all the way around, giving it a near-complete panoramic view of its surroundings, a field of vision that is almost unparalleled. Scientists studying the mysteries of mantis vision have even designed and fitted them with tiny, custom-made 3D glasses to test their depth perception, confirming beyond any doubt that they possess a form of three-dimensional sight that is unmatched among other invertebrates. This ability makes the mantis a hunter of the most extraordinary and elegant precision, able to snatch a fly from mid-air with a grace that seems both effortless and profound. When it slowly and deliberately tilts its head toward you, It is not simple curiosity that moves it, but the quiet, cool calculation of a creature that truly and completely sees the empty space that exists between our two worlds. In the secret, complex hierarchies of the insect world, a perfect disguise can mean the difference between life and death. Some species of beetle have evolved to look, to smell, and even to behave so perfectly like ants that they can live entirely undetected deep within the heart of bustling ant colonies. Over countless generations, their bodies have grown slender and segmented, their antennae have become gracefully curved, and their very movements have been rehearsed into a perfect, flawless imitation of their hosts. More than just a physical disguise, they have mastered a chemical one as well. They can produce the very same complex chemical signatures that the ants themselves use to recognize their own nestmates. In this way, they can walk freely and confidently among their unwitting hosts, sometimes stealing food, sometimes feeding on the colony's own larvae, or sometimes simply enjoying the profound and constant safety of the fortified nest. The deception is so absolute, so utterly flawless, that the ants often treat them as cherished family, grooming them and protecting them as if they were one of their very own. It is a living, breathing example of how deeply and completely adaptation can sculpt the very identity of a creature. The beetle's strange, borrowed life is a quiet masterpiece of survival, an art of deception played out in the hidden, fragrant darkness of the soil, deep within a kingdom that is ruled by the invisible languages of scent and of silence. From this master of imitation, we now journey to the lush, verdant rainforests of Madagascar to meet one of nature's strangest and most wonderful craftsmen, the giraffe weevil. The male of this species has a neck so extraordinarily long that it can be up to 3 times the length of his entire body, a bizarre and wonderful structure that he uses for both building and for battle. When constructing a nest, the weevil uses his elongated neck with the skill of a master artisan, carefully and patiently rolling a single tough leaf into a perfect tight tube. Inside this protective and meticulously crafted cradle, the female will lay a single precious egg. The leaf nest eventually falls to the forest floor, where the larva will hatch safely hidden from the dangers of the world. The males also use their incredibly long necks in slow, deliberate duels with one another, locking together in a ritualized, almost graceful combat for the right to mate. Despite their strange and seemingly awkward proportions, giraffe weevils move with a quiet, deliberate grace, their glossy black shells catching the soft, green filtered light of the high canopy. They are living, breathing sculptures, a quiet and beautiful proof that evolution creates not only for pure functional necessity, but also for the sheer, unbridled artistry of adaptation. Finally, we return to the language of light. To our human eyes, the gentle, drifting glow of fireflies may seem random and magical, a spontaneous decoration of the summer night. But to the insects themselves, it is a precise and deeply meaningful language. Each species uses a distinct and unique rhythm and pattern of light flashes to attract mates and to recognize one another in the dark. Some species exchange simple call and response signals, while others perform intricate, timed sequences, a form of Morse code written in pure living luminescence. In the still, warm air of a summer evening, their silent messages flicker across meadows and forests, weaving invisible conversations of attraction, of courtship, and of response. The light itself is produced by a perfectly efficient chemical reaction within the firefly's body, a reaction that is controlled with an astonishing and beautiful precision. And in some species, the females have learned to be deceptive, perfectly mimicking the patterns of other kinds of fireflies to lure unsuspecting males closer, turning the language of communication into a tool of cunning predation. Every single flash of light carries a specific meaning, from love to danger, from courtship to deceit. Their glowing, silent dialogue turns the vast darkness into a form of living poetry, a gentle and luminous proof that even the smallest of lives can express themselves in the beautiful, ephemeral patterns of light. And now, as our long and quiet journey through this hidden world comes to a gentle close, let the last wings settle and the soft ambient hum of the world grow still. Let your thoughts begin to drift, weightless and free, like soft feathered moths moving through the deep velvety fabric of the night. The great forests, the moonlit meadows, the quiet dreaming soil that lies just beneath us, all of these places whisper the same single, endless and profoundly beautiful story. It is the story of life, small and impossibly tireless, a life that is forever building, mending, glowing, and dreaming in the darkness. In the deep, silent hours of the night, their intricate worlds continue, completely unseen by us, woven together by a million tiny movements, each one too gentle, too subtle for our waking eyes to ever follow. Every single leaf holds a silent architect. Every patch of damp green moss is home to a tiny, courageous explorer. Every breath of wind carries a whispered chemical message that we will never understand. So close your eyes now and allow your mind to paint a gentle picture. Imagine the deep, iridescent shimmer of a beetle's shell, a rainbow of colors that exists only in the structure of light itself. Imagine the soft, golden pulse of 1,000 fireflies lighting up a forest in a silent, synchronized breath. Imagine the secret, fragrant murmur of a hive, alive and warm with a single unified purpose. The earth itself breathes through these countless delicate lives. It is a slow, steady, and ancient rhythm of renewal that never, ever stops, not even when the rest of the great, noisy world finally goes to sleep. This unseen kingdom is the planet's patient, meticulous foundation, a world of tireless artists and engineers who work not for reward, but for the simple, profound continuation of life itself. They are the keepers of the soil, the guardians of the air, the quiet weavers of the intricate web that connects all living things. Their lives are stories of perfect adaptation, of impossible resilience, and of a beauty so profound it can be found in the most unexpected of places, in the silent language of a dance, in the shared warmth of a living raft, in the inherited memory of a migration that spans a continent. They show us that strength can be found in softness, that intelligence does not require a voice, and that the grandest of miracles are often the smallest and the most overlooked. Their world is a quiet testament to the idea that every life, no matter how brief or how humble, contributes to a pattern that is vast, ancient, and deeply meaningful. If you have found a measure of peace on this quiet journey with us, I warmly invite you to express it in your own way. Perhaps a quiet like, a gentle subscription, or a soft thought shared in the space below. It helps other sleepy souls find their way to this quiet harbor, a place to rest from the noise of the day. But for now, your work is done. It is time to rest. Let your mind drift away now through the soft, hidden gardens of the deep night. Let it wander through forests of glowing light and meadows that sing with silent, unheard music. And let the gentle, whispering world of wings and whispers carry you now, softly and completely, into a deep and truly peaceful sleep. Soft, wondrous, and perfectly still. Good night.